Alright, for those who don't want to wait and maybe you've done 3, 4, and 5 on your own and you want to double check that you have it done correctly, I'm going to go ahead and show you how I do them. So for number 3, I'm going to go ahead and do it the long way, and then maybe for 4 and 5, I'll do half and half. So first thing we need to do is read the problem. So it states, if 20 liters of oxygen are consumed in the above reaction, how many liters of carbon dioxide are produced? So remember, we circled the information they give us. So we were given 20 liters of oxygen, and then the question asks how many liters of carbon dioxide are made. So we need to box the 5 moles of O2 and the 3 moles of carbon dioxide because they are referenced in the question. So for all intents and purposes, we can ignore the 4 moles of water and the propane. Now, once we identified our 2 important compounds, let's go ahead and write out the molar ratio. So the ratio between the O2 and the CO2 is simply 5 moles of O2 is equivalent to the 3 moles of CO2. Remember, these numbers just come from the coefficients that are in front of your compounds. Alright, so when we go ahead and start our conversion, let's start by writing what they give us in the question. So we're going to start with 20 liters of oxygen. So we're going to write, let me zoom in, 20 liters of O2 over 1. That's step 1. Let's move on to step number 2. Step number 2, we are going to convert liters to moles. So we're going to cancel out the liters of oxygen by putting that unit here, and we're going to convert to moles of oxygen. So if you don't remember, the conversion is 22.4 liters for every mole. And now we can go ahead and cross out our liters of O2. Alright, let's go to step 3. Step 3 is we need to refer to our molar ratio, 5 to 3. So we want to cancel out the O2, so we're going to put moles of O2 down here, and then moles of CO2 in my numerator. So our ratio is 5 to 3, so 5 moles of O2 for every 3 moles of CO2. And we can go ahead and cancel out these units. If I'm going too fast, just rewatch it. And finally, the 4th step is just kind of like the reverse of step number 2. So we're going to put moles of CO2 in my denominator, and we're going to get liters of CO2 in my numerator. So it is 22.4 liters for every 1 mole of, CO2. So we'll go ahead and cancel out the mole of CO2, and we are left with, let me zoom in, liters of CO2 as my unit. So recall that in order to get the final answer, we just need to multiply across. So we multiply all our numerators together, sorry about that, and we get a final numerator, and we multiply all of our denominators together to get a final denominator. Now to make the math a little bit more easy, we can go ahead and cancel out the 22.4 right away, so we don't need to even bother putting them into our calculations. So we're going to multiply 20 times 1 times 3, which is 60. And we're going to multiply 1 times 5 times 1, which is simply 5. And we're going to go ahead and simplify our fraction, and we're going to get 12. And we carry the unit that we derived and include it into our answer. So we end up with 12 liters of carbon dioxide that's produced. Okay. Now, mind you, if you would have skipped step 2 and step 4, you would have got the exact same answer. You would just need to double check that you carried the correct units. All right. Quickly to number 4. I'm going to go ahead and do the short way for this. So let's read the question. The question asks or says that we have 30 milliliters of hydrogen, and 30 milliliters of hydrogen are produced in the above reaction, and it asks how many milliliters of oxygen will be made. So we go ahead and underline that, and we're going to square our O2. We're going to circle 30 milliliters of hydrogen. We're going to square our hydrogen, so we don't need to look at the water. Let's go ahead and write our ratio. So for every 2 moles of H2, we have to combine it with 1 mole of O2. Remember, if there's nothing in front of the compound, we assume it's 1. So that's where we get the 1 from. And just like all the other examples, we're going to start our conversion with the number we were given. Now, it's pretty convenient to do the short method whenever we have a unit that isn't in liters, because we do not need to bother with converting milliliters to liters. So we start with 30 milliliters of H2 over 1. Erase that. That's our step 1. Remember, we're skipping steps 2 and 4, so we're going straight to step number 3, which is where we look at our ratios. So we want to get rid of H2, so H2 will go on the bottom, and then O2 will go on top. So our ratio is 1 to 2, so for every 1 O2, we require 2 H2s. We can go ahead and cancel out our H2s because there's 1 in the numerator and the denominator, and we're left with milliliters of O2, and that's going to be our unit. Now all we need to do is multiply across to get our final answer. So we're going to do 30 times 1, which is 30, and 1 times 2 is 2. So 30 over 2 is simply 15. And that is our answer, 15 milliliters of oxygen. All right, number 5, last one. Let's go ahead and break this down. There's actually 2 questions, so let me just underline the 2 questions right now. So the first part of the question says, how many liters of carbon dioxide are produced if 75 liters of carbon monoxide are burned in oxygen? So we're going to answer number 1 right here. So in the question, it asks for how much CO2 is made, so we're going to put a box around that. And it says we start off with 75 liters of carbon monoxide. That's CO. So we're going to put a box around that. So for question number 1, let's ignore the O2. Now let's go ahead and write the molar ratio, which is very simple. It's just 2 moles of CO for every 2 moles of CO2. Now, you can technically do this in your head if you understand how molar ratios work, but I'm going to go ahead and just show you the full entire steps. So we started off with 75 liters of carbon monoxide, so I'm going to go ahead and write that here. And we'll put that over 1. And remember, we want to cancel out the liters, so we're going to convert it to moles. So remember, it's 22.4 liters for every 1 mole. We can cancel out the liters. Okay. Now the second step is our molar ratio. So we're going to take moles of CO and convert it to moles of CO2. And our ratio is 2 to 2. Cancel out the moles of CO. And finally, the last step, we can just convert moles of CO2 to liters of CO2, and that's going to be 1 for every 22.4 liters. I'm sorry, I'm a little messy. And let's just go ahead and cancel out what we don't need. So, bam, bam. Remember, 22.4, we can just go ahead and cancel that out right away. So now we're just going to multiply 75 times 1 times 2, and 1 times 2 times 1. So we're going to get 75 times 2, which is 150 over 2. And this simplifies to, let me write it in a little nicer color, to 75, and the last unit, liters CO2. That's how you do number 1. Let's go ahead and look at number 2. I'm going to go ahead and erase this so we can have more room to write. Now number 2 asks how many liters of oxygen are necessary. So when we go back to our reaction, we're going to be interested in 2 CO2 and the O2. We're not going to worry about the product anymore. So let's go ahead and fix our ratio. So it's 2 CO2s for every 1 mole of O2. So it's 2-to-1 ratio. Let's go ahead and do the short method for this. So we start off with still 75 liters of carbon monoxide. We're going to skip to the ratio step. So step number 3. This is step 1. We want to get rid of CO and we want to convert it to O2. The ratio is 1 to 2. Cancel the COs out. So it's going to be liters of O2 in our answer. Let's write that. Okay, so we're going to do 75 times 1, which is 75. 1 times 2 is 2. Going to simplify that, and the answer is going to be 37.5 liters of O2. Now, I hope I wasn't going too fast. Again, if you need to go back and rewatch a section, I encourage it. Also, the shorthand step is optional. If you're not my student and you have another instructor or something like that, double check that this is something that they approve. For me, I think it's perfectly okay since the math works out. It's just a little bit of a kind of a shortcut. But beware, make sure you do have the correct units in the end, and you should be all good to go. So thanks for watching, and I will see you in class.